Hey guys, in this video we are gonna talk about sodium potassium ATPase. Now, this sodium potassium ATPase are integral membrane proteins or pumps that pump potassium ions and sodium ions against their respective concentration gradients. Now, since the potassium ions are in less concentration outside or in extracellular fluid, they move these potassium ions against the concentration gradient inward into the cell where they are already in higher concentration. Now these guys pump the sodium ions from the intracellular fluid outward all the way into the extracellular fluid where they are already in higher concentration. So it is very easy to understand that since they are pumping these two ions against their concentration gradients, so they must be utilizing energy in this case, which does happens because of its ATPase activity, which breaks down the ATP and couples its energy to utilize it to move these ions against those concentration gradients. Okay, now let us dive into the phenomena. How does this happens? Okay, now here are the two specialized binding sites on the extracellular domain of the alpha subunit of this sodium potassium ATPase, which has got two subunits, alpha and beta. Okay, now the alpha subunit has got specialized receptors or specialized binding sites for the two potassium ions. Okay, here those potassium ions are gonna bind. Okay, now on the intracellular domain of the alpha subunit, there are three receptors or three binding sites for sodium ions. Now these sodium ions are gonna bind here on the intracellular domain of the alpha subunit. Now what happens during one ATPase cycle when these two potassium ions are bound on the extracellular domain of the alpha subunit and three sodium ions are bound on the intracellular domain of the alpha subunit, the ATPase activity of this guy is activated. Then what happens? Once its ATPase activity is activated, once its ATPase is initiated or activated, it breaks down the ATP into ADP, releasing one inorganic phosphate. Now what this inorganic phosphate do? This inorganic phosphate autophosphorylates one of the amino acids in this alpha subunit. Now you might have gone through this concept that when some of the amino acids of the proteins are phosphorylated, they become either activated, the protein or polypeptide become either activated or deactivated, which basically happens due to the change in conformation. Now once this ATPase breaks down the ATP into ADP, releasing inorganic phosphate, this phosphate autophosphorylates its alpha subunit. Now once this alpha subunit is autophosphorylated, some of its amino acids change their conformation, due to which the whole alpha subunit gets changed in its conformation, pulling those potassium ions inward and pushing those three potassium ions outward from the cell. Now basically the degradation of ATP by the ATPase releases inorganic phosphate, which basically changes its conformation, pulling those potassium ions inward and pushing these three sodium ions outward, both against their respective concentration gradients. Now this was the whole cycle of the ATPase activity. Now you must be thinking about that what happens when these potassium ions or these three sodium ions by any other reason would not be able to bind to these binding sites. Now in case of hypokalemia, when there is low potassium outside, obviously these potassium ions are gonna bind less, so it's this ATPase activity of this sodium potassium ATPase will be less, and Similar the case is when either of its functional units, either potassium or sodium or its ATPase activity is decreased, the whole functioning of the this ATPase is decreased. Okay, the whole of the cycle of the ATPase activity will be working efficiently when all these entities like potassium ions, sodium ions, and ATPase of its own activity is working efficiently. Now, let us dive into the energetically favorable phenomena. How does this phenomena is energetically favorable? Okay, let us discuss the point when ATPase activity was initiated due to the binding of the 2 potassium outside and 3 sodium ions on the intracellular domain of the alpha subunit. ADP formed, and this ADP is ADP was formed, and this inorganic phosphate autophosphorylated this alpha subunit. Okay, now at this phosphorylated state, if the concentration of the if the energy stored in the concentration gradient of these ions were greater than the energy stored in the bonds of the ATP, then no transport of these ions would occur. Instead, these ions would move down their concentration gradient, synthesizing ATP. So that was the energetically favorable cycle, and this energetically favorable phenomena happens in the working of all of the receptor ions and channels. So that was all about regarding the sodium potassium ATPase. Hope it made sense.